Firstly, I must thank everybody who is here because there are very few people as it is. But nevertheless, I must thank all of you for making it here. And I hope to make it interesting for you all. Am I audible? That end? All right. Fine. We're going to talk about an interesting topic which is getting a lot of attention today in the media, and that is war driving. Right. Just to give you an idea of the popularity of wireless networks, I have put in place a few statistics and a few areas which are driving this particular need. It is assumed that today we have about 3.5 million access points worldwide, likely to grow to about 2000, by 2005 to about 4.5 million. And these are very conservative estimates looking at the popularity of wireless. What is driving this need, or what is driving this growth in wireless? Primarily, I have divided it into two parts. This is the business need and also the convenience need. For the business need, it gives a great amount of flexibility to mobile users. The moment you enter your office, your building, you are online. And it increases the employee productivity by allowing anywhere, anytime, mobile computing. And definitely, when you are starting to implement a network from the scratch, it has much lower implementation and setup costs. When you look at convenience, I am sure all of you appreciate that there can be nothing better than having this tangle of wires removed. If I can help it, even the power supply should be wireless. And that is where we are headed in the future. Right now, just the connectivity is wireless. So it is very flexible. It is easy to configure, easy to maintain, inexpensive. Building and office considerations I briefly talked about. Lower implementation costs. Home users can go anywhere and be connected. And there are these technology enthusiasts who are working at using this. What are the risks in wireless LAN implementations? And these are the risks which directly relate to war driving. So I mention them here. The SSID, the service set identifier, is broadcasted. The access point wants everybody to know I'm here. So it is telling everybody, this is my address, come home on to me. That is the basic setup, that is the basic architecture. While there has been an attempt to have the content passing through wireless networks encrypted, it has its flaws. The protocol which is in use is the WEP, Wireless Equivalent Privacy Protocol, but it has its own limitations. Notwithstanding those limitations, there was a survey carried out in Hong Kong, and they realized that only 23% of wireless implementations had their WEP enabled. This is something which is coming with the setup, yet people are not doing that. Access points located within the firewall. Typically, one would assume if I put everything in the firewall, everything is safe. But putting an access point within a firewall is the biggest mistake a network administrator or a network security planning person should be making. Having DHCP enabled on the wireless LAN inside the firewall. Now, what is DHCP? It is essentially enabling a person or a computing device to get a dynamic IP address the moment he enters the area of influence or the access range. So you walk in with your wireless device enabled computing device. You go into an access area which is covered by a wireless access point. If it has DHCP enabled, it will give you a dynamic IP on the fly. You will not have to carry out any access control, any configuration change, and you would now be a part of the wireless network. User login authentication is not required for a lot of wireless networks, even in corporate setups, because in the name of giving flexibility and compatibility, they are not, and ease of use, they are not enforcing login authentication, which ideally should be done using a radius server. And these are all multi-directional, undirected signals, so anybody could be using them. The wireless equivalent privacy protocol, which is the de facto standard which is being used, has proven and published weaknesses and vulnerabilities. Right? It is easy to break, and the key management is not a functionality which is available. So just to show graphically how it's very simply depicted here, that a malicious client who is not supposed to be a part of the network, if he can get access to the access point being on the other side at the same range, he would have access to information on the network. The same thing can be used in ingenious ways by people who have malicious intent. This could involve a client-to-client attack. That means you are now a part of the network, so you can decide to attack any other client. So that's a client to C2C attack. And you could also be attempting to jam the access point so that there is a denial of service. These are some of the areas in which risks are definitely staring all wireless security implementations in the face. And here, what has been depicted is a fake access point. As the name suggests, it is an access point which is purporting to be an access point which, assuming the identity of another access point. By doing that, it is now reaching that overlap region, and it will get access to the entire network on the wireless. So what's the problem? What happens when somebody gets access into the network? The LAN broadcasts its own position. It is broadcasting its own SSID, as I talked about. Using that, data can be captured without physical access. You really don't need to travel into that area. You have an antenna, and which is looking out, which will seek the signal, and you will still be able to get that despite staying off-site, and network resources can be hijacked. And what is biggest problem is that it is easy. Take it from me that it is even possible with a Pringles can or with a PVC pipe to create an antenna and walk by or drive by, and that's what we're going to be talking about. Obtaining this access to corporate wireless networks. Why I have specifically said corporate wireless networks? We must not assume wireless access from the Starbucks or the Coffee Beans perspective. That's a different wireless network. That is a public wireless network, which has its own DHCP enabled. They want people to come in and use it without authentication. But that's not what my company or your company should be wanting to do. Because you would be opening out the network to an external intruder and opening out all the company confidential information to them. It's almost today a sport bordering on getting into an obsession for many people who are continuously engaged in this. A survey in Hong Kong, we'll talk more about it a little later, but it's relevant, I mention it here. Within a year, they found that the number of access points when they did a war driving survey, this is one of the few published war driving surveys, and within a year they found that the number of access points had increased more than double, and what they realized was that only 23% of them had their WEP enabled. So war driving is the act of driving around with a computing resource, which could be a laptop or a PDA, a wireless card, and software to identify the wireless access points. And thereafter, it is up to the ingenuity of the user to do malicious use of the particular access that he has been able to obtain, he or she has been able to obtain. So what are the hardware tools which a war driver would be employing? He would look at having the computing resources we talked about, a wireless card, a GPS, a global positioning system would add to his functionality. We talk more about that later, a power supply adapter if it's doing it in a car, and antennas. Now antennas are not mandatory. If you can go and park your Jeep inside the access point, you don't need that antenna. But if you want to do it remotely, you don't want to go physically and travel into that point, you could have antennas which would, and if you increase the gain, then you can increase your range away from the actual location of the access point. So what kind of a computing resource? It is a basic computing resource. easily transported computer, 486 or faster is good enough. What it must have is a PCMCIe slot for the wireless card. A lot of today laptops are coming enabled with wireless, and a serial port for the GPS if you are into serious war driving and you want to do it in the real war driving sense. Operating system could either be Windows, Linux, and even any of the other flavors which are supported by these wireless cards. Antennae. It is optional to have an antenna, as I have covered, but it is a must in case you want to remain at a distance. And most of these wireless cards today come with jacks for the antenna to be plugged in. But if it is not there, the innovative ones, they are modifying these cards using some wires and other means to enable an antenna to be plugged into the wireless card. And as I said, it's very simple to make an antenna, though there are specific antenna today available in the market at very, very low cost. The wireless cards are, as I covered earlier, the standard 802.11b cards, and most of them are today coming in the PCMCIe form. And the earlier versions also had some single station adapters, which would act as media translators between wireless and an Ethernet card. For the Linux, however, only the ISA card works, while Windows supports both of them. All right. It's not supposed to be a workshop in war driving, but I guess it's somewhere close to that. If somebody wants to do it after this, probably you'll be able to do that. Otherwise, you need to go to Google, is everybody's good friend, and go and ask for a tutorial on war driving, and I'm sure you'll get the right kind of links. See, there is a connotation to war driving which makes us think that it is all bad, it is all illegal. It is not so. The survey which has been done in Hong Kong was to find out what is happening about it, and let's do something about it. So it is like any other vulnerability scanner. You could have a vulnerability scanner which could be viewed as a hacker's tool, but it could also be a network system administrator's tool or a security manager's tool. Talking about GPS, if you have to scan a very large area in a very short period of time, either you have to be very good with your memory and you remember all the street names and in quick time, and you can make a very good mention of it on your software. If not, it is ideal to have a GPS inbuilt into the software. And most of these softwares which help you do the war driving, we'll talk a little about those, definitely support the integration of GPS. Right? So the programs would log the exact coordinates down to a few feet of the effective range of the wireless LAN, and they use the standard GPS protocol, which is called the NEMA, and they dump it continuously to a serial port via the cable 96008N1. Some of the software tools, known software tools, which I have listed here, and they are platform-based. They have Linux-based Kismet, ASNOT, WEP Crack, and Wellen-Rita. We have the Mac OS, Max Tumbler, AP Scanner. For the pocket-based, PC-based, very popular because it can be used on the PDAs, Mini Tumbler, Sniffer Portable, Air Scanner Mobile, and also the Win32-based Net Tumbler, AeroPeak, Sniffer, and Ethereal. We also have an ISS software for doing this. So how is there a method to this war driving? I guess there is a method to everything, and this method broadly shown here is about planning the entire war driving effort. It also goes down to having a little bit of intelligence on known wireless networks, and thereafter you undertake the scanning using the software by making yourself positioned in that area within the wireless range. Capture the information, the basic information, map that network. Once you've mapped the network, then you attempt to penetrate the network using various means. So is it good or is it bad? As I said, it has a bad taste to it. War driving appears like hacking, but it all depends from what perspective are you seeing it. If tomorrow I'm in charge of the security of my hybrid network, I would like to do war driving, right? So it is all It's all about making sure that your own networks are secure, and it depends on how you look at it. Fine. The next question is it legal or is it illegal? Well, if you are simply driving around a city searching for the existence of a wireless network, nobody can fault you for it because you have no ulterior motive. But if you're searching for a place to steal internet access, or you're committing a computer crime, or seeking to commit a computer crime, then you have a malicious intent, and it could be deemed so in a court of law. Just to give you an example, while the regulation is definitely a step behind as it happens in most issues of advancement of technology, there is no regulation which is specifically addressing war driving. But in some countries, simply receiving radio transmissions on the cellular telephone frequencies is illegal. Right? So a similar law could actually come up against war driving, but none exists as of now. So the issue is that technology per se is not bound to ethics, but it is how you're going to use what you can using this technology which has to remain ethical. Very thin line between using it in a malicious intent and without. So the estimate is that there are going to be 25 million people using commercial hotspots within a year, and there's just a few statistics as I brought out earlier. Between the 2 years, from 187 access points, and it gone to 473 plus 257 in an adjoining area. And there are not many such services available, so I think the growth in the ASEAN region for wireless networks is going to be fairly huge. So while the one element is about the vulnerabilities, how war driving is happening and how it could be conducted, what are the tools? I've talked about the hardware tools, the software elements, and the procedures for doing it. Now, how do you make sure that your network is not vulnerable to a war driver, or your systems can be made war driving proof? First and foremost, you must put the access point outside of the perimeter firewall. This goes against normal thought process. Everybody would want to put everything which it wants to secure within the firewall. But in this case, if this access point, which is shown here, if this access point was to be inside the firewall, it would have access to this entire local area network of the organization. And it is also broadcasting this for mobile users. So it would actually be taking the information from within your LAN and broadcasting it to the rest of the world. Whereas if you place it outside and you enforce security by other means, which I will talk about, right? And make sure that only authorized users are able to access that. That is the architecture that you must have, and that happens when you're setting up your architecture. So how do you make sure that only the authorized users have access? One very, very robust means of doing that is at the physical layer in the API stack is by using MAC address access control lists. That means simply that if there is any user who's going to enter the access range of a particular access point, he would have to get authenticated. The machine address, the MAC address of that particular device physically has to be entered in the particular access control list of that access point. Only then an access has to be enabled. Only then that particular user will have access to the wireless network. It is at the physical layer as has been shown here. So it is not possible to use just one means of ensuring security in a wireless environment, just as it's not possible to do it in any other environment. You have to have what is called defense in depth. You have to have a layered approach to security, an onion peel approach to security, with your information or your assets remaining in the center. A second element that we talk about now is to have a closed network deployment, making sure that the default SSIDs are changed and you disable the broadcast. Now here, a closed network has been demonstrated. You have to treat the wireless LAN as an external network. The same thing which we talked about earlier, putting your access point outside the firewall. Use VPN and use strong encryption. Do not use DHCP for the wireless element, and install it in a separated network altogether. Change the default SSID and disable broadcast. All right. Another element that has to be enforced is the element of encrypting the content. Let us say the two elements that I talked about in securing your wireless network architecture have been breached, and a determined intruder who's got through. Just like a suicide bomber always gets through, a determined intruder will definitely get through. Once he is inside your network, he gets access to the content on your network, whether it is company confidential information, your credit card number, or such other confidential information. If you have enabled encryption by using systems which are available, WEP is a de facto security protocol which comes shipped with most equipment, but often it is not enabled. And as I talked earlier, it has its own known and published vulnerabilities. So if you are able to use the next level, which is called the temporary key integrity protocol, in which it is evolved from the WEP, initially called the WEP2. It has got the same strength of the algorithm as far as 128-bit algorithm is concerned, but the temporary key is changed after every 10,000 packets. So what happens is, in case a person has got access to your network and he obtains the key, derives the key out of your network using a software, that key is only temporary, right? And will not remain valid for the rest of the sessions. Also, it is advisable, even in the wireless space, to implement a VPN to make sure that the element of sniffing, if you are creating a virtual tunnel into your access point, so there is very little chance of any other person being able to get through. I have shown here, depicted here, how without VPN encryption, a sniffer would be able to obtain information from an access point in which there are FTP servers interacting with each other. All right. And without VPN encryption, this is how the clear text is going to move from point A over to point B. But in case you are using a VPN, there is going to be the flow from A to the access point will have a secure tunnel. A secure tunnel which will make sure that the sniffer which is standing on the outside will not be able to get access. What he will get access to is gibberish, which will be of no use to man or beast. All right. As in any conventional network, authentication is a very strong element of security. It is recommended that even in a wireless network architecture, use of a very strong central authentication mechanism like the Radius remote authentication dial-in user service be used. The same is shown here. You have an access point. You have a request being generated, a two-way handshake happening between the wireless client and the access point. And once the handshake is complete, initial handshake is complete, we move on to point number 4, where the Radius access is requested. The authentication is happening after the access point has given a MAC address authentication from the access control list. It is now sending an access request to the Radius, the central remote authentication dial-in user service server. That is the server which will have information of authentication, and the second handshake takes place and the authentication is done. So if you have an architecture which builds in these components that I'm talking about, you have a reasonable security posture. all that we have talked about till now is focusing on technology. But is technology all there is to it in any network architecture? So what else there is? I would request somebody to hazard a guess. Technology is an element which must be addressed, and that's what we've been talking about till now. What are the other elements which need to be addressed in any security environment? Yes, so it's about processes. I would put it as three blobs that should be maintained. It's people, processes, and technology. All of these have to blend to make sure that you have a very strong security posture. When you talk about policies, these are the processes which you have to make sure the policies are implemented enterprise-wide. Everybody is aware of the policies and they are complying to it. Let us say you have an employee who leaves the company today. How soon are you going to revoke, or are you going to revoke the access control from the Radius server immediately? Is there a policy in place? Is it being followed? How soon are the passwords, username, logins being changed? So is there a policy to that? If tomorrow you add another access point, is there a policy in place to ensure that all the security features which you're currently using as per the last security audit are also employed there? If you don't do any of these, even one slippage here could actually remove your security posture, and you could land up being very, very vulnerable. So also, in hybrid networks, the threats emerging out of non-adherence to policies and procedures are much larger. You have a few legacy legacy computing systems and networks. These have to mesh seamlessly with the wireless network. It's not even fathomable to see what are the security vulnerabilities or bugs that it is going to throw up by having a new wireless component added. So all of this has to be viewed in a holistic manner and a security policy defined to address these issues. Right? Today, there are manufacturers who are giving you advanced security features already inbuilt into your systems. Whether I talk about the TKIP, there are systems available with that. There are systems available on maintaining wireless VPNs. So it is a choice when you're deploying to try and seek those technologies which give you advanced features. So it amounts to having a requisite amount of security consciousness to look for these features and go ahead and deploy them. The policies have to ban rogue networks and have to have a system of scanning for rogue networks. It's about the fake access points that I talked about. So now, to conclude, I would like to share with you how our company, Network Security Solutions, MSc, SD and BHD, which is operating in Kuala Lumpur for the last 2 years. We have operations worldwide in the US, Singapore, in the ASEAN region, Brunei, as well as in India, Sri Lanka, Bangladesh. We have implemented a large number of networks, including some campus-wide networks up to the range of 450 acres. The issue is, when you're doing your implementation from the scratch, you need to have a holistic view to the hybrid network security. And it must encompass the three elements that I talked about: people, processes, technology. Just putting in place those devices is not good enough. And your security posture must remain dynamic. That's the last point here, written here. Be dynamic. I cannot put in place my processes, procedures, and my technology elements and say, fine, now I have just got the audit done, an external penetration test done, everything is in order, I'm secure. You are secure as on today. There is nothing guaranteeing that you will be secure tomorrow. So you have to have a dynamic security posture. Second, a secure separated deployment architecture, a very important element of our approach to implementing hybrid network security. Defense in depth. There cannot be one single technology element which will ensure your safety from war drivers or from war hackers. You have to have multiple layers of security, making sure that your information assets are protected right in the center. Go in for equipment which gives you the advanced security features. It is possible, it is affordable, and that is what must be done. And do all of the sensible things that I talked about in this entire talk. Build practical policies and make sure there is strong commitment from the management to ensure the compliance of all of these. That's all. Thank you very much for your kind attention. If there are any questions, I would like to address them now. Yes.
One thing that you didn't touch upon is even if you have a network that is entirely cable-based,
Yes.
now because the technologies are so easily available, it's possible for somebody to either have physical access,
Okay.
place a wireless component in there, and
Within
somebody
that.
on a LAN-based network is actually not LAN-based network, it's wireless.
Absolutely correct.
Do
That's
you have any?
yes, yes, that's a huge vulnerability. But how that can be tackled is if you go to the physical layer of the protocol stack and make sure that you enable MAC address authentication, right? So even if you have a wireless antenna, like you said, a wire placed right in the center of that access network, when the information has to pass, it has to be a handshake happening. There has to be authentication happening. If you enable it at the physical layer, by looking at the MAC address and having that access control list for the MAC address, this will not happen.
I was actually going to ask whether you think the risk of this happening is high in your experience, whether people have been trying to do this.
Yes, it is high. Right? The fact is that relatively today, the threats are not perceived so much because wireless networks are only about now beginning to explode in their usage. And it is when the community which is sitting in the other room, the technical people there, the community which is much more organized, when a vendor, a wireless security product vendor is got his own security team, there are a bunch of, let's say 10, 20, 100, up to 300 people working on security. But you look at the underground, they are collaborating in an unprecedented manner today. Information today is being shared in such a strong manner, and this kind of a collaboration is leading to a much better performance from their side. All right. So it is going to be a question of time when they decide to focus their entire efforts into this, and vulnerability is going to increase. But as of now, for corporate networks, not much of it is happening, and that's our personal experience. Yes.
You just spoke about doing ACLs based on MAC addresses on the APC cell.
Yes.
What if you're dealing in large organizations? It
Pardon?
wouldn't be so practical to put a huge amount of ACLs.
Yeah, you're right. That works essentially for small organizations.
So
That is
large organizations.
large organizations. There are other. See, it's a multi-layer. You have to have a radius. A large organization has to have a radius, right? So it's you have to have a holistic view. Make sure you have minimum 2 to 3 layers of security enabled, and you continue to refine it. If you add another access point, you've got to look at how it is going to impact your entire architecture. If you're going to place it in a location which is going to change the security posture, you've got to address that immediately. But a very valid point. I think it is not mentioned there that it's only for small networks that you'll be able to enforce the ACLs that we're talking about. Right. Thank you very much, and thank you for your questions as well as your attention. Bye-bye.